All right, guys. So today we're going to be beginning talking about how to divide exponents with like bases. So we already know how to multiply exponents with like bases. We already know how to take some sort of power and raise it to another power. So now we have to talk about what happens when we are dividing our like bases. So in these problems here, you can see that we have a base of 5 in the numerator, and we also have a base of 5 in the denominator. So this problem is not fully simplified until each base only appears one time. So since I have a base of 5 here and a base of 5 here, this is not simplified. So what this really is saying that you have 5 to the 6th power. So that's 6 fives, 1, 2, 3, 4, 5, 6. And you're dividing those 6 fives by 2 fives down here. Well, when we divide, what happens is the like pieces cancel out. So this 5 and it's going to cancel out this 5, and this 5 here is going to cancel out this 5. So what I'm left with here in the numerator is 1, 2, 3, 4 fives. So that's 5 to the power of 4. And in the denominator, I don't have anything left, so it's just 1. And 5 to the power of 4 over 1 is just 5 to the power of 4. So I want you to think about this sort of as we go through these. Right now, we ended up with a base of 5 still, and our exponent was 4, and we had a 6 and a 2. All right, so let's look at the next one here. So in the numerator here, I have to have 7 sevens. So that's 1, 2, 3, 4, 5, 6, 7. And again, they're all being multiplied. And in the denominator, I have 4 sevens. 1, 2, 3, 4. So again, it's not simplified because I have 2 base 7s. So when I go to cross out pairs here, that's gone, that's gone, that's gone, and that's gone. So what I'm left with is 1, 2, 3 sevens. So that's 7 to the power of 3. Down here, I don't have anything left. So it's 7 to the power of 3 over 1, which is just 7 to the power of 3. So again, I had a base 7 in both places. And again, I had a 7 and a 4, and I ended up with 7 to the power of 3. All right, continuing along here, this one is going to have 9 fives. Nope, 5 nines. 1, 2, 3, 4, 5, and then 3 nines. 1, 2, 3. We go to cross them out here. That goes away. That goes away. That goes away. And we are left with, well, that's 2 nines. So that's 9 squared over, nothing left here. So 9 squared over 1, which is just 9 squared. Well, we all know that 9 squared is actually just 81. So that would be our final answer there. All right, so we're going to continue along. There again, we had a 9 here, and then we had a 5 and a 3, and we were left with a 2. All right, so these ones are going to be a little bit different, but very, very similar. So let's see what we can do here. So I've got 4 2s here. 1, 2, 3, 4. Here I've got 6 2s. 1, 2, 3, 4, 5, 6. So when I go to cross out my pairs here, I have in the numerator nothing, so I put a 1. And in the denominator, I have 2 to the power of 2. So there I had 2, I had a 4 and a 6, and I had a 2 here. So I know that 1 over 2 squared is actually just 1 over 4. So that would be my final answer there. All right, last question here. We have 3 to the 4th. 1, 2, 3, 4. 3 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. So now I'm going to cross out things that are like here. Ooh, there it goes. And in the numerator, I'm left with nothing, so that's 1. In the denominator, I have 1, 2, 3, 4 3s, so that's 3 to the power of 4. And since that's not one of our summer math facts, the exponent is 4 or higher, I'm done, and that's my final answer. So again, I had 3, and I have a 4 and an 8. So when you look at the pattern here, what happens here is the base stays the same every single time, right? So the base was 9 here, it's still 9. The base was 2, it's still 2. It's still 3. And then if we look at the relationship here, we had 6 and 2, and then we ended up with a 4. We had 7 and 3, and we ended up with or we had 7 and 4, we ended up with a 3. 5 and 3, we ended up with a 2. 4 and 6, we ended up with a 2. 4 and 8, we ended up with a 4. So the relationship between these is actually subtraction. So when you are dividing exponents, the base stays the same, and you subtract the exponents. Now the last thing we have to know there is where the actual base goes, because sometimes it's in the top here, sometimes it was in the bottom. So the base stays in the part of the fraction where the exponent is higher. So if we look up here, we had 5 to the 6th over 5 squared. Well, there's 6 is bigger than 2, so it stayed in the top, and 6 minus 2 is 4. But down here, we had 2 to the 4th over 2 to the 6th. Well, 6 is bigger than 4, so the 2 stayed in the bottom, but 6 minus 4 is 2, so that's why our exponent's still 2. So again, that's our rule there, and now we're going to look at some examples here. So we're going to do these ones sort of together, and then you can do these two by yourself, and then there's one more thing we have to look at, and then you have a 5-question skill check, and that's it. So today should be pretty easy. So right here, if we are looking at this problem here, I can tell that I have 8 to the 8th over 8 to the 4th. So now the first thing I want to think about is where is my 8 going to end up? Well, I have 8 8s up here and 4 8s down here. I have more 8s in the numerator, so I know my answer, my 8, is going to stay in the numerator. So now I have 8 minus 4, so I end up with 8 to the power of 4 over 1, and that's just going to be 8 to the power of 4. All right, so hope that makes sense there. So now we're going to go down to this next one here. And in this one, again, we have a 12 in both places, so we know we're going to have a base of 12 in our answer. We have a 20 up here and a 7 down here. Well, 20 is bigger than 7, so my base of 12 is going to end up in the numerator. And 20 minus 7 is 13, and that would be 12 to the power of 13 over 1, which is just 12 to the power of 13. All right, well, let's keep going here. So in this one, I have 4 to the power of 4 over 4 to the power of 9. Well, I have a larger exponent here in the denominator. So my 4 is going to be in the denominator, and still 9 minus 4 is 5, so it's 4 to the power of 5. But now, because the power was bigger in the denominator, I have to make sure that I remember it's 1 over 4 to the power of 5. And that's not the same thing as just 4 to the power of 5. When that denominator base is bigger, you have to make sure you leave the answer where its base is in the denominator. So you have to keep it as a fraction. So if we're looking at these ones here, we have a situation where we have 5 to the 8th over 5 to the power of 4. Well, we have a bigger exponent in the numerator, so 5 goes here. 8 minus 4 is 4. So I end up with 5 to the power of 4 over 1, which is just 5 to the power of 4. All right, so I want you to hit pause in just a second, and I want you to solve both of these two out, see what you get, and then hit play and check your answers. All right, so here we All right, so things are going to get a tiny bit more complicated, but not a lot more complicated today. So looking at this question here, one of the things we might notice here is that these don't even have the same base. So we're actually not going to be able to combine these two. But what we do notice is we have this negative here. And we are not allowed to have a negative exponent in a simplified answer. So some of us might remember that what we do with a negative exponent is that we put it in the denominator of a fraction. So what these negative exponents are going to mean to us all this week is that we flip where that piece is. So right here I have 3 to the power of negative 2. Well, that's a negative exponent, so I'm going to have to bring it down to the denominator. Now 2 to the third power, that's already a positive exponent. That's fine. It stays right there. We don't move that. We don't move positive exponents. We only move negative exponents. So if I have 3 to the negative second here and I have to move it to the denominator, there's nothing left in the numerator. So when there's nothing left in the numerator, what we put there is a 1 to indicate that this whole thing is actually being divided by 1. Well, now 2 to the power of 3 was already down there. And now 3 to the power of 2 has come down to join it. So now I have 3 to the power of positive 2. Now we might be tempted to try to continue here. We might be like, oh, like bases, let me add here. But when I think these aren't like bases, this is 3 squared, and this is 2 to the power of third, or 2 to the third power. So technically this is simplified. Now, some of you might want to go a little bit further because you know what 3 squared is. You know that it's 9. So this is actually 9 times, well, 2 to the power of 3 is actually 8. So this is actually the same as 1 over 9 times 8, which is the same as 1 over 72. But again, this is a simplified answer because you have each base only appears one time and you have positive exponents. So in this next one here, we have a situation where the denominator is negative and the numerator is negative. So this one's going to switch to the bottom and become positive, and this one's going to switch to the top and become positive. So a negative tells you to flip it and make it positive. So 3 to the negative second comes down here and becomes 3 to the positive second. Well, 3 to the negative third comes up here and becomes 3 to the positive third. Well, if I go to look at this, this is not simplified because I have a 3 base here and a 3 base here. So now I know my answer is going to have a base of 3, so I have to figure out whether it goes in the numerator or the denominator. Well, this exponent is bigger than this one, so I know that my 3 will stay in the numerator. Now I do 3 minus 2, which is 1. So I end up with 3 to the power of 1 over 1, which is just 3 to the power of 1, which is just 3. So in this next question here, we're going to solve it very similarly. So now 3 squared is already up there. It's already positive. I don't need to move that. So in my answer here, I'm still going to have 3 squared. Well, now 3 to the power of negative 4, that needs to come up to the numerator. So I have 3 squared times 3 to the power of positive 4. Well, there's nothing left in the denominator here, so I put 1. Well, now I am multiplying like bases. So I'm going to have my like base of 3, and then 2 plus 4 gives us 3 to the power of 6 over 1, which is just 3 to the power of 6. So these types of problems here are actually starting to put together the different pieces here. So we're going to do just 5 more problems, and then you're going to have a 5-question skill check in Canvas, and then that'll be it. All right, so in this question right here, and again, if you want to, you can sort of pause this video. You can work out these questions here. So can I zoom this so you can see more? Yep, okay, so I zoomed it out. So if you want to pause, you can pause and you can work these ones out, and then you can press play to check your answer. But I'm also just going to work these out step by step for those who want to see it that way. So in this first one here, I know that this negative exponent needs to flip down to the bottom. So there's not going to be anything left in the numerator. And this is going to be 5 to the power of positive 2 times 2 to the power of 3. Well, I can leave it like that if I want to, because these are not like bases, so I can't combine them. Or since technically these are summer math facts, I know that 5 squared is 25. I know that 2 to the third power is 8, and then 25 times 8 is actually 200. So that's the same as 1 over 200. But if you had this answer here, that's also correct, as long as you don't try to combine these because they don't have like bases, but that's equal to 1 over 200. Looking at the next one here, I have 7 to the power of negative 2. Well, that needs to come down to the denominator because it can't stay negative. So in the numerator, there's nothing left, so it's 1. Well, this becomes 7 to the power of positive 2 times 7 to the power of positive 3. Well, if I think about that, I shouldn't have that base of 7 appearing 2 times. So I'm still going to have a base 7, but I'm going to add my exponents, which is what I do when I multiply those like bases. So 2 plus 3 gives me 5. So my final answer here is 1 over 7 to the power of 5. All right, continuing on here, I'm going to take my negative exponent and I want to deal with that before I even start. So here I'm going to have nothing left in the numerator, so it's 1 over, well, 6 to the power of negative 4 is going to become 6 to the power of positive 4, and I already have 6 to the power of 3 down there. So this is going to become 1 over 6 to the power of 4 plus 3, so 1 over 6 to the power of 7. All right, next one here. This one's fun because we have two negatives, so I have to flip this one to the bottom and this one to the top. So I'm going to end up with 2 to the positive second in the denominator and 2 to the positive 13th in the numerator. Well, we should know that that is not simplified because the base of 2 is appearing in the numerator and the denominator. Well, 13 is bigger than 2, so the 2 is going to live in the numerator, and 13 minus 2 is 11. So I've got 2 to the power of 11. That piece is gone away, so all I have here is my final answer is 2 to the power of 11. All right, final question here before your skill check. So here I've got a negative in the denominator. I need to move it up because you can't have a negative exponent. So this becomes 5 to the power of 4. That stays there because it was positive. This comes up to join it, and I have 5 to the power of 3. Nothing left in the denominator, so I put 1. Well, again, I can't have that base of 5 appearing twice. So this is going to be 5 to the power of, well, when I multiply like bases, I add my exponents. So 4 plus 3, 5 to the power of 7 over 1, which is just 5 to the power of 7. So if you've really worked these out, the skill check should be really easy. They're going to look just like this, just with different numbers. So go ahead and get that done right now. And then tomorrow, what's going to happen is we're going to have a Zoom class at 1 o'clock where we're going to start looking at questions like these ones. So things are going to start to get a little bit more complicated. So tomorrow we'll have a Zoom class to discuss questions like this. Wednesday, you'll have a little like a 10-question practice on these type of things. Thursday, I'll do another little instructional video, just practicing questions like these big ones here, because these ones are a little bit more complicated. And then Friday, you'll just have like a 5-question skill check with these type of problems. So again, not a huge amount of work, but I want you to do the work well because it's not too much. You have the time and you have the intelligence, so please get it done. And I will see you guys in Zoom class tomorrow. Bye.